Okay, good morning, all of you. So, in today's class, we are going to discuss about the list of keywords used in exception handling mechanism. Okay, so in the previous class, we have seen that what is meant by exception handling, what is exception and what is exception handling. So, that's what we have discussed in the previous class. Okay, so what is exception? Basically, we know. So, exceptions are the runtime errors. Exceptions are the runtime errors are known as exceptions. So, and what is exception handling? So it is the process basically. So the process of handling, the process of handling. So raised exceptions or the raised runtime errors. So is known as exception handling. Okay. So this is what we have seen in the previous class. Okay. So exceptions are basically runtime errors. So runtime errors are known as the exceptions. Okay. So as we have seen, there are two types of errors in a Java program. So one is called compile time error, and second one is called runtime error. So one is the compile time error, second one is the runtime errors. Okay. So compile time errors are we have shown some examples like we were missing semicolon, okay, missing double quotes, and invalid or use of undeclared variables, or misspelling of identifiers. So use of single equal to in place of double equal to. So these are all some most commonly used compile time errors. And also we have seen what are various runtime errors like division by zero error. Okay. So if there is a division by zero error in a program, so that is one type of runtime error. And second one is the array index out of bounds. Sometimes the index of the array may be out of bounds, out of its limits. That is, if the index exceeds its upper limit. Okay. So in such case, an exception may be raised. Such an exception or a runtime error is known as array index out of bounds exception, and other errors like number format exceptions, that is conversion from string to integer, so leads to a runtime error. Okay, that is another type of exceptions. So these are all some types of runtime errors, also known as the exceptions. So this is what we have seen in the previous class. So what is exception and what are common exceptions? Okay. Now in today's class we will see these keywords, and also we have seen the exception class hierarchy. So we have seen that exception class hierarchy, that is the top level exception hierarchy. We have seen this diagram also. We have covered the previous class. Okay. So this is the throwable is the top level class in the exception class hierarchy. Now there are two subclasses for this. One is the exception, and second one is the error. One is the exception, and second one is the error. So these two are the subclasses of the top level exception class, that is throwable. Okay. So coming to this error class, so this is the one of the branch of this throwable. So that is called this error class. Okay. So now this error class basically defines exceptions that are not expected to be caught under normal circumstances by your program. So our program will not handle this type of runtime errors. Okay. So the exceptions of this type of error are used by the Java runtime system. So basically these type of errors are indicated, are used by our Java runtime system or Java runtime environment. So basically used to indicate errors having to do with the runtime environment itself. Okay, for example, there is an error called stack overflow. So it is an example of such an error. Okay, that is the runtime error. So stack overflow will be the one of the example. Okay. So running that is Stack Overflow will be occur when some base cases were missed in the what it is called recursion approaches. So suppose if there is no base case or the recursive process or the recursive function, for example, I want to calculate factorial of a number using recursion, suppose. Okay. So you need to write one base condition. Suppose if n equal to 1, then you should return 1. Otherwise, return x star or n star fact of n minus 1. N star fact of n minus 1 you should return. So if there is no base condition, then what happened? It will goes into an infinite loop so that the stack will be overflow. So now these type of errors are comes under this error category. This type of exception, this is also occurred at the time of the execution, during the execution of the program. So that it is known as the runtime error. Okay, this is called the runtime error and it comes under the category of this error. Okay, so this is one branch of this throwable class. And another branch of this throwable class is the exception class. So this is the base class for runtime exception class. This is the base class for a runtime exception class. So now the exceptions of this type are automatically defined for the programs that you write and include things such as division by 0 and invalid array indexing or negative array indexing or array index out of bounds. Now these type of errors are commonly comes under this particular subclass of this throwable known as the exception. So now for this exception class, there is a child class. What is that child class? Runtime exception. There is a class known as the runtime exception. This is another branch. So these runtime exceptions are our what it is called runtime exceptions are comes under the checked exceptions. Okay, this is what you have to find out. Okay. So these are comes under this runtime exceptions. Okay. So what are runtime exceptions? Division by 0 and invalid array indexing. These type of exceptions are comes under this runtime exception class. Okay. So whenever there is an exception in general in our program, so whenever there is an exception, if you consider C and C++, there is no built-in exception handling mechanism in this particular C and C++. But when you consider this Java, Java provides built-in exception handling mechanism. Java provides built-in exception handler. Now our Java runtime system provides built-in exception handling mechanism. Okay, built-in mechanism to handle our exceptions. Okay. So if there is an exception, what happened is in the case of C and C++, if there is a division by 0 error in case of C and C++. Now what happened is the program may goes into infinite loop here. But when coming back to this Java, there is a built-in exception handler is there. Built-in exception handler provided by our Java runtime environment. So now this is going to handle our exceptions. Okay, by default, the default exception handler will be there. So that is any exception that is not caught by our program. Okay, suppose if we are not caught your exceptions. Okay, so these will ultimately be processed by the default handler provided by Java. Default handler provided in the Java. Now the default handler displays a string describing the exception and also prints a stack trace. Prints a stack trace from the point at which the exception occurred and it terminates the program. Okay. So instead of going into infinite loop, what happened is our Java built-in exception handling mechanism. Our Java built-in exception handling mechanism is going to handle our exception Suppose if we are not able to catch the exceptions and not able to process our exceptions, then what happened? So internally within the Java, there is an exception handling mechanism or the default exception handler is there. Okay, our Java runtime environment provides default exception handler. This default exception handler is going to handle our exception. That means it is going to displace the information about the exception, that is a string describing the exception, and prints a stack trace. Stack trace means this is the description of the particular exception. Now, which one has occurred first? Suppose there are multiple methods are throwing exceptions. Okay. Now the stack holds the list of exceptions, the list of methods thrown a certain exception. Okay. We'll see one example also. Okay. So, and simply after displaying the information, after displaying this stack trace, that is the description of the exception, and the program terminates abnormally. Okay. So now to illustrate this, let us see one example. For example, this is my exception handler EH class in there. Okay. So suppose, so I'm writing this. So let us take, so integer a equal to 10 and take b equal to 0, suppose, and write one statement system dot out dot println. So division is, suppose a by b. So this is in general, this statement leads to a division by 0 because this is a by b means it leads to a division by 0 error. For example, Java C exception handling dot Java. Now Java exception handling EH. Now here there is a division by 0 error actually here. Now our Java default handler, actually there is no exception handling here. So in my program, so I did not mention any exception handler here. There is no exception handler in this particular program. But still, this program is going to handle the exception. Okay. So what it is? So because internally Java runtime system provides, our Java runtime system provides a default exception handler. There will be a default exception handler. Now this default exception handler is going to handle this exception and provides the description about the info exception. What is this exception in thread main? Okay. What is that exception? Java.lang. Arithmetic exception. Because this arithmetic exception class is a member of the package lang Java, our default package java.lang package. So it describes the complete information. That is, what is the exception name here? The exception name is the arithmetic exception. What is my exception name? Arithmetic exception. So what is that arithmetic exception? Division by 0 at, so what is my program name here? EH, my class name is EH in the method where in which method the exception was raised. That is in the main method itself, exception was raised. Where exception caught? In the main method. Okay, that is the program name eh.java colon 8. What is this 8? At line number 8, exception was caught. That is, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, including these blank spaces, it will count. Right? So this is the exception handler, default exception handler. So prints the information about the exception and then it is going to terminate. Okay. So automatically this particular program terminates after describing the exception. Okay. So for example, this is the stack trace. Okay, description of the exception along with this method name and the line number where the particular exception raised. So for example, let us take one method here. So static void disp, one display method is there. Now instead of writing this particular code, I want to write the code here itself. I want to write the code here itself, suppose. So this is my program. That is the one method, that is static void display. So here A is equal to 10 and B is equal to 0. So I want to perform division operation. I want to perform division operation. Okay. I want to perform a division operation here, right? So then I want to invoke this particular method here. Okay, DISP. Okay, invoke this particular method in main. Now let us see what will be the stack trace. Now earlier this one. Now let us see what will be the stack trace. Now compile this and run. Now see here earlier exception in thread main. Exception in thread main. So what is that exception? Arithmetic exception. This is same. Division by 0. Now this line is same. But next one at eh.display. At eh.display. Okay, what is the method name? Display here. What is the line number? 6. And next at eh.main. Now eh.java at line number 10. Now when you call this particular method display, this is going to cause a division by 0 error. Division by 0 error. So that's why this is going to display the first main method name, that is the bottom of the stack contains eh.main and top of the stack contains display method. Okay, eh.display method. This is the stack trace. Okay. So suppose another method will be there. If display calls another method, now this is going to invoke another method. Okay, like that the stack holds all these particular method names while displaying the information about the exception. Okay. So this is the general procedure. What happened when the default exception handler is going to handle. Okay. So this is about the top level exception class hierarchy and what are various classes available and what happened when there is no exception handling mechanism. Okay. So I hope you understand this particular scenario. So now let us see how this exception handling mechanism works in Java. So what are various keywords available in Java to handle the exceptions? Okay, that is the list of keywords used in exception handling mechanism. So as we told in the previous class, so there are two blocks, that is what are various steps available in exception handling mechanism. Okay, what are steps in exception handling mechanism? We know what are steps in exception handling process. What are the steps in exception handling process? So the very first step is to hit or find the exception. The very first step, as we discussed in last class, is find the exception and then throw the exception. Second step is throw the exception. And third step is catch the exception. Catch the exception. And then last step is take the necessary action. Or this is also called handle the exception. Handle the exception. So these are the 4 different steps in the exception handling process. Okay. First one is the find the exception and throw the exception and catch the exception and handle the exception. So these are the major steps in the exception handling mechanism, exception handling process. Now in order to perform all these, so we need a list of keywords in Java. We need a list of keywords in Java. Now what are those keywords? Now the very first keyword is, so there are 5 keywords are there. There are 5 keywords. Okay, used to handle exceptions. One is try, second one is catch, and third one is throw, and fourth one is throws, and fifth one is finally. Okay, so these are 5 different types of important keywords used in exception handling mechanism or exception handling process. Okay, so what are those 5 important keywords? One is try, and another one is catch, and next one is throw, and another one is throws, and next one is finally. These are 5 important keywords used in exception handling mechanism. Now, what is the purpose of each keyword? We will describe. Okay, we will give the outlines, and next we will see one by one its importance with the help of the example program. Okay. So now basically this try keyword is used to define a block of code, define a block of code. So that may raise exception. Okay. So now the keyword try is used to define a block of code or write a block of code. So this code may raise a particular exception. Okay. So this particular block of code might raise an exception. Suppose there will be a chance of raising exceptions or runtime errors by this particular block of code. Then keep this block of code inside this try block. Okay, so that is the purpose of this try block. Okay, and the next important keyword is the catch. Now this block it is used to receive the error information or exception. Okay, receive the exception object. Okay, and handle it. So it is used to receive the exception object. So it is thrown by the try block. So that is inside this try block, whenever there is an exception, if there is an exception raised by this particular block of code, so then the try block immediately creates an object of that particular class, an object of that particular class, and it is thrown to the this particular catch block. Immediately the catch block follows this try block, so that the catch block receives the exception object, and it is used to handle the particular exception in a proper way. So that is the purpose of this catch block. And third one is the throw keyword. So now it is generally used to create our own exceptions, and it is also used to throw the exception object. It is also used to throw the exception object. Okay. So the keyword throw is used to create our own exceptions, or sometimes it is used to explicitly throw the exceptions. It is also used to explicitly throw the exception object. Okay. Or suppose you want to throw an exception, that is arithmetic exception is there. Okay. No, I don't want to handle it. I want to handle in a different place. So that what we can do is throw this particular exception object. Okay. Using the keyword throw. And next one is the keyword throws. The keyword throws is used to declare objects that are declare exceptions. Declare exceptions that the method might throw. Declare exceptions that the method might throw. Okay, suppose if my method is throwing an exception, okay, if my method is throwing an exception, but that I don't want to handle it, then what you can do is use this particular keyword throws and then specify the exception that you want to throw. Suppose the main method, my main method is throwing an exception called IO exception. IO exception, that is during working with the concept of files, if the file is not traced, if I am unable to open a particular file, okay, so then it tries an exception called file not found exception, or any other input output exceptions are there, read write exceptions are there, okay, so that the method don't want to handle these exceptions, but these exceptions may be thrown by a particular method. Okay, declare the exception that a method might throw. Okay, that is arithmetic exception and array index out of bounds exception and file not found exception and IO exception. Different exceptions are there. So these exceptions are thrown by a particular method. Then use this particular throws keyword in the method signature. Suppose public static void main. Now in the main, this particular main method throws IO exception, then specify IO exception or any other exception called file not found exception or arithmetic exception, whatever it may be, but to specify there. Okay. So this is the purpose of the keyword throws. And coming to this finally, it is used to define a block of code that executes always regardless of exception occurrence. Okay, defines a block of code that executes always regardless of the exception occurrence. Okay, so that is there will be a block of code that I want to execute always. Okay, so regardless of the exception, whether an exception will be raised. Okay, exception may be raised or it may not be raised, but I want to execute some block of code always. Then keep this particular block of code. So inside this finally block, inside the finally block, because this finally block always executes. Okay. So this will not include any catch block. There is no need of writing any catch block. Okay. There is no need to write any catch block for this finally block. That is, if you want to define something without any catch block, then what you should do is go for this finally keyword. This finally block contains some statements or a block of statements. So those statements executes always. Okay. And these statements will not depend upon the exception condition. Okay. Exception condition. Right. So if there is an exception, it will execute. If there is no exception at all, again it will execute. That is, it will not depend upon the exception. So that what you have to do is, so use a block, keep a set of statements or a block of code inside this finally block if you want to execute this code always, regardless of the exception occurrence. So that is the purpose of this finally keyword. Okay. So these are all 5 different important keywords. Out of these 5, there are 2 important keywords most widely used in the exception handling process. Okay. So one is called the try, another one is called catch. One is called try, another one is catch. Now, in the exception handling process, there are 4 steps as we mentioned. So what are those 4 steps? So one is called find the exception, throw the exception, catch the exception, handle the exception. Okay. So now again, these 4 statements, 4 stages are again further divided into 2 blocks. Okay. This is one block. This is another block. Okay. These 4 steps are further divided into 2 different blocks using these keywords. One is called first 2 steps are comes under one block. Second two steps are comes under another block. Okay. So these first 2 steps are handled by this try block. Okay. First 2 steps are handled by try block. Next 2 steps are handled by catch block. Next 2 steps are handled by catch block. Okay. This is one block. This is another block. Okay. So these are the 2 steps. Step 1 and step 2 are handled by this try block. Step 3 and 4 are handled by this catch block. Okay. There are 2 important blocks in the exception handling mechanism. One is called the try block. Another one is called catch block. Okay. So now let us see these 2 blocks. Suppose. So I'll show you. I'm erasing this particular part. Okay. I am removing this. So now we have how many blocks? 2 blocks. This is one block. This is another block. Okay. This is one block and this is another block. Okay. So this is called try block. Why it is called block? So these statements should be enclosed in between open and closed brackets. Okay. Second one is called catch block. Try block and the catch block. Now, what is the purpose of this try block? As we mentioned in the previous class, the purpose of this try block is this includes statements that cause exceptions, statements that cause exception, and catch block statements to handle exceptions. Statements to handle exceptions. Okay. So these are the 2 different blocks. These are the 2 different blocks. One is the try block, another one is the catch block. Now, whenever there is an exception, now the try block, what happened is, so when an exception is raised, okay. So now inside this try block, inside the try block, it creates, or Java runtime system creates an object of that particular type, because each and every exception contains its own exception class. Okay, its own exception class. For example, arithmetic exception is there. Now it consists of arithmetic exception class, and array index out of bounds exception. Now it has array index out of bounds exception class. Okay, like that. For each and every exception, there will be a corresponding class, so that it is going to create an object of that particular class inside this try block. Our Java runtime environment creates an object. Okay, so creates an object of that type, and it will be thrown to catch block. Okay, it will be thrown to the catch block. Okay, this is the purpose of this particular try block. What happened inside this try block? Now, once this particular catch block receives the corresponding exception object, now it is going to handle this particular exception. It is going to handle this particular exception. That is, catch this particular exception object and take the necessary action. For example, if it receives arithmetic exception object, it receives arithmetic exception object, arithmetic exception, suppose E. Now it is going to handle this particular arithmetic exception appropriately. Okay, it is going to handle this arithmetic exception appropriately. Okay, so these are the two different blocks. One is the try block, another one is the catch block. These two blocks performs these four steps: find the exception, throw the exception, catch the exception, and handle the exception. Okay, so this is the process of handling exceptions using the two important keywords. One is try and another one is the catch. Okay. So now let us see its basic structure or the basic syntax of this try block and the catch block. Okay. So now what is the general syntax? What is the general syntax of this statements? That is try, because it is a block, you need to enclose it. You need to enclose the block of statements with open and the closed bracket. Using open and the closed bracket. That is a try and then open, and you need to write the code here. Whatever the code you want to enclose here. Immediately after try block, you should write the catch. Catch. Here you need to specify exception type and its object. You need to specify exception type and its object, and you want to write the code to handle it. Whatever the code you want to write, you can write here. Okay. So this is the general form of this exception handling code. Okay, exception handling code. Now first one is the, here you have to write one try block, and immediately after try block, again you need to write one catch block. Okay. So for every try there should be a matched catch block. Okay. For every try there should be a matched catch block. Suppose the try block handles arithmetic exception. Try block handles arithmetic exception. Then you need to write, you need to handle the you need to catch the arithmetic exception object using this catch block. Using the catch block. Okay. So this is the general syntax or the general form of this try and catch. Okay. So for example, if you want to write one example, suppose I want to handle the division by 0. Let us take integer a equal to 10 and b equal to 0. Suppose now I want to perform int. Suppose int c is equal to a by b. Int c is equal to a by b. Now this statement is going to raise an exception called arithmetic exception. Exception called arithmetic exception. Okay. So here you can write system.out.println. What is this type of error? This is a division by 0 error. This is an error of type division by 0. Okay. So now this is the simple example which illustrates the concept of exception handling. Okay. So now in this particular example, the catch statement in the syntax, the catch statement takes exception type. What is the exception type here? Type of exception thrown by this particular try block. Okay. Suppose if it is a division by 0 error, what is this division by 0 error? This class comes under arithmetic exception. This comes under arithmetic exception. So that you need to write arithmetic exception here. In the catch statement, you should write arithmetic exception. Okay. So now if b is equal to 0, this is going to raise a division by 0 error. So that arithmetic exception, it is going to raise an arithmetic exception. Okay. This is called arithmetic exception, right? So inside this catch block, so you can write the description of the error, that is division by 0. Okay. So for example, if you want to see this, This is division by 0. So this is what I want to perform. Control X here int A B. So this is release this, delete this. So this is control C. But again, I want to write another statement. Addition is suppose A plus B I want to perform. I want to perform addition. So even though there is no problem with this particular statement, now see what happened first before going to incorporate our exception handling mechanism. Let us see what happened. Java C and Java. So exception, that is arithmetic exception, division by 0, and the program terminates abnormally, even though there is no problem with this particular statement. So that what we should do is, so you need to write this particular statement, because this is going to raise an exception inside the try block. Inside the try block, we should write this. Okay. So try, and after try, immediately what we should do is catch. You need to write one catch statement. Catch. What is the exception type here? Arithmetic exception. E. What is the type of the exception? Arithmetic exception. Now inside this, you can write something here. So this is a division by 0. Okay, this is the thing you need to incorporate here. This is the thing you need to incorporate here. Okay, so catch arithmetic exception, that is system.out.println. This is division by 0. Okay, now see what happened. Now compile this code and run. Now it is going to display the information about the exception, that is division by 0. Then it will execute the remaining statement, that is addition is, that is 10, 10 plus 0, that is 10. So not only this one addition, you can write any statements, whatever it may be. So after an exception is exception caught. So what happened is the execution will continue from there. Okay, after handling this particular exception, it is going to execute the rest of the statements. But in the earlier case, what happened? The program terminates abnormally. So that with the help of this exception handling mechanism, what we have to do is we can avoid the abnormal termination of the program. Okay, what we can do? We can simply eliminate or avoid the abnormal termination of the program, so that we can handle the exception or the runtime error and proceed with the block of code or the block of statements which do not have any runtime errors, which do not cause any runtime errors. That is the advantage of this particular exception handling mechanism. This is the proper way of using this particular try and catch blocks. Okay. So sometimes what happened is a single try block may consist of multiple catch blocks. Okay. Multiple catch blocks. That is, sometimes there might be a chance of raising multiple exceptions within a single try. So that in such case, what I have to do is, now it is also possible to include multiple catch blocks in a program. Okay. Multiple catch blocks in a program. Suppose in my exception handling process, what happened is if a try block is going to throw two types of exceptions. Okay, so this is my try block. So you can write the code here, whatever the code it is going to generate an exception, and write here. So exception type 1 and its object, and write your code here to handle this object. and write another catch statement. Okay. So this is exception type 2, object 2. So you can write code here and so on. Like that, you can write catch exception type n and object n. Like that, you can write any number of catch blocks. Okay. So that is a single try block may throw multiple exceptions. Okay. A single try may throw sometimes multiple exceptions. Now, in such case, what you have to do is you can write multiple catch blocks. This is a one catch block. Okay. This is another. This is another catch block, and so on. You can write multiple catch blocks. Okay. This is catch 1, catch 2, catch 3. Now, this particular catch statement is going to catch a specific exception, and this particular catch statement is going to catch another exception. This one is going to catch another exception, like that. Okay. Suppose in a program, this is my program. This program is going to generate two exceptions here. One is suppose division by 0. One is division by 0. And another exception is suppose array index exceeds. Okay, in such case, what you have to do is you need to write two different catch blocks here. That is catch. What is the first one? Arithmetic exception. Arithmetic exception E. Then write the code here. Okay. And write another catch statement. What is that array? This is array index out of bounds exception. Okay. Array index out of bounds exception. This is another one. Okay. So this you can write. So this is the way of handling multiple exceptions. Way of handling multiple exceptions. Okay. So you can write two different multiple catch blocks. This one multiple catch statements. Okay. Or otherwise from Java 7 onwards, you can also combine these two exception types in a single catch. Okay. So from Java 7 onwards. Okay. So there is a provision. So now the same catch statement. So you can write like this catch. Okay. What it is? Arithmetic exception. Then you can use the connectivity R and then write array index out of bounds exception. Okay. Okay. Sorry, this. Array index out of bounds exception E. Okay. So now this statement. So out of bounds. This is exception. Sorry, this one. Array index out of bounds. Okay, array index out of bounds exception. So that means using this logical OR connectivity, so you can interconnect these two types of exceptions, arithmetic exception as well as array index out of bounds exception. These two exceptions you can interconnect. Okay, catch arithmetic exception or array index out of bounds exception. Instead of writing two catch blocks, you can catch multiple exceptions in a single catch statement. This is also valid. Okay, so this is the process of handling multiple catch blocks. Multiple catch blocks. Now let us see one example. So this is my program. So integer a b equal to 0, and let us take one array. Integer arr is equal to 1, 2, 3. So there are three statements in this particular array, three values. So here this is I want to perform division, and at the same time, so instead of what you have to do is okay, keep it as it is, and ARR of 99 is equal to 100. So I want to initialize my array with 100. Error of 99. Actually, the index 99 does not exist. What is the array index actually here? This is 0, this is 1, this is 2. Okay. This is 0, this is 1, this is 2 index actually. Okay. So, but index does not exist here. Okay. So, what I want to do is I want to handle this arithmetic exception first, and I want to handle array index out of bounds exception. Array index out of bounds exception. Okay. So here, what I want to do is I want to write array index exceeds. Write one statement here, array index exceeds. Okay. So catch array index out of bounds exception and this one. There are two exceptions are there here. Okay. Now in the first statement in the try block, there are two statements. Now the first statement calls arithmetic exception, that is division by 0. Second statement calls array index out of bounds exception. Okay. Now what happened here is it will not handle both the exceptions. Okay. It will handle only one exception, that is the first occurrence of exception only will be handled. For example, if there is a division by 0 error, then immediately it is going to create an object of this arithmetic exception type, and it is thrown to the corresponding catch block. First, it is going to verify the first catch block. If the first catch block matches, it is the corresponding object thrown by this try block. Then it is going to execute the corresponding catch block. The first catch block will be executed. Okay. So remaining all catch blocks will be ignored. Okay. Suppose if there is no problem with this first statement, it is going to execute the first statement. Then it comes to the second one. If there is a problem with this second statement, then it is going to construct object of this particular exception, because this exception is array index out of bounds exception. So it is going to throw an object of type array index out of bounds exception. Then it is going to search the corresponding catch blocks. First catch block it is going to check, so it will not match, so that it is going to search for the next catch block. What is the next catch block? This one, array index out of bounds exception. So it is matched. The corresponding catch block will be executed. Okay. So it will not, even though multiple exceptions it is thrown. Okay. It will not handle all multiple exceptions. Okay. Only one exception will be executed. Okay. So now let us compile the code Java C, EH, and then Java. So now see here, actually, in fact, there are two exceptions. This array index out of bounds exception is also thrown. but it will not handle that. Okay. So it is going to throw only the first one, first occurrence. Okay, that is division by 0. Suppose instead of writing division, suppose this is 2 instead of 0, now it is 2. Now again compile the code and run it. Now the division is 10 by 2, that is 5. Now next statement, when it comes to the next statement, ARR of 99 is equal to 100. It is going to generate an exception called array index exceeds, array index out of bounds exception. So that it is going to generate array index out of bounds exception. So it is going to execute this particular catch block. Okay. So this is how to handle multiple catch blocks. Okay. So as I told in the concept of this multiple catch blocks, instead of writing two different catch statements, you can write one catch statement. Okay, by combining this statement like this, arithmetic exception, and use one logical connectivity R and use array index out of bounds exception. Then remove this. Here you can write simply exception caught. Okay. Simply write exception caught. Okay, this is also valid. The CEH. Now this is the exception caught, that is array index out of bounds exception. Okay. So like that you can use multiple catch blocks in a single try. With a single try, it is possible to write multiple catch statements. So these are the two important keywords you have covered in today's class. Okay. So one is called the try block, another one is called the catch block. Okay. So in the next class, we will see about this throw and throws and finally. Okay. Throw and throws and finally.